Hello everyone, welcome to my YouTube channel. I'm thrilled to have you here today because I'm here to embark on a journey through the world of Rido. Rido, Rido is a ride-sharing software, and Rido is not just a riding platform. It's a visionary ecosystem meticulously designed around a sophisticated booking system that unlocks a world of possibilities for every rider. And coming to the problem statements, inefficient driver passenger matching, suboptimal route planning, real time demand management, and user experience, and also the environmental impact. To address these challenges, the ride sharing platform project seeks to develop a system that optimizes driver passenger matching, enhances route planning, provides real time demand management, and delivers an exceptional user experience. And by addressing these all problems, the project aims to create a cost effective, convenient, and environmentally responsible ride sharing solution for both drivers and passengers. And coming to the futures of Rido, the, the main features of Rido are efficient driver passenger matching. And the primary goal is to create an intelligent matching system using priority queues and also optimize the route calculation and, and real time demand management and enhance user experience. Now, I will explain about the data structures that are used for the creation of this project. The main data structures that here used are priority queues, graphs, arrays, and lists. Now here I will explain the functionalities of priority queue and how it will be implemented in this project. Priority queue. Priority queue is an abstract data type similar to a regular queue or a stack. Here, each element in a priority queue has an associated priority. In priority queue, elements with highest priority are served before the elements with lower priority. Basically, we know that in queue we will follow the first in become the first out. Like that, in priority queue, it will work as per the priorities, highest priorities. Now, I will explain how we implement the priority queues in this project. Here, let's consider these nodes as a users. User 1, user 2, and user 3. Here, I will store the ID of the user. Here, I will store the priority of the user. It will, in this block, we'll store the address of the next node. It became now. So here I'll give the ID for the user 1 as 1, for ID for the user 2 I'll give 2, and for user 3 I will give 3. And the priority here I will give as, for user 1 I'll give 5. Here higher the number means higher the priority. I will give here 4, and here I will give 2. Now the user one have the highest priority among the all the next two users. So this will become the first user. So whenever the booking is available for booking is available for a rider, the user one will get the chance to book the rider. So it will get the first priority. Now if a new user to be added to the queue, so he or she may have the it will be based on the priority queues. The new node will be the new user will be added in between the already existing users. So for example, I'm creating a node that user 4, for example, he is the new user, and and his id is 5, and he have a priority of 3. So now how I will insert this priority queue means I will iterate through the already existing nodes. Here the this user have a priority of 5. So I cannot exist him because he have a 3, which is 5 is greater than 3. So he have highest priority compared to the new user. So I will go to the user 2. User 2 have 4 priority and he have 3. So user 2 also greater than user new user. So I can't remove him. So now I can compare here. Here the user 3 have the priority of 2 and new user have a priority of 3. So 3 is greater than 2. So I can add the new user here. Now I will add in between the user 2 and user 3. I will add the new user. We have a ID 5 and priority value 3, and it will connect like this and it will connect like this, and now this will become the user 4 and the new user will become the user 3. Like this the implementation of priority queue will be taken in this project. Now I will also explain the code implementation of priority queues. So coming to the code explanation, here we usually libraries, and now coming to here we created a structure named as user, and we are a create here we have created a multiple structures for user and driver. First we have created a structure called user structure for a user, and in that we have given in id and priority. For as per same we also given for the driver same like user, and driver will also have a id and priority. Here we used in integer for the ids and priorities. Now we created a node for data, means void pointer to data. The pointed data will directly connects to the data of the user and also the driver. Here we implemented a and here we created a priority queue and node pointer friend. Node pointer friend means here the top higher the priority value user will get the first service among the other the users. So no, the node will directly connect to the front. Init priority queue. Init priority queue means here we create an empty queue, which empty queues are here empty queue is most efficient for creation of a new nodes for adding a new user and or else adding a new driver. So we for that priority queue here we are assigning the malloc means we have here implementing the size for the inserting of data. Q here q arrow front equal to null or return q means, which means either the starting of the queue is null, front is nothing is there, then it will represent it will return to the queue. For nq also we are again we are here we assigning a for new node we are assigning a malloc of size of node, means here again we are assigning the memory for allocation and implementing the code. Here if this condition I will explain this condition. If q arrow front is equal to null or priority is less than user pointer q arrow front arrow data arrow priority. Hey, Now coming to here, this line, priority queue pointed to the init priority queue. Here we created init priority, which means the empty queue. And priority queue pointer queue is equal to priority queue pointer malloc size of priority queue. Again here come to queue arrow front equal to null and return queue, which means this function initializes a new priority queue and returns a pointer to it. And the and the queue is initially empty. Next, void enqueue bracket priority queue pointer queue comma void pointer data comma init priority, and this line initializes this. The enqueue function adds an element with data and priority to the priority queue while maintaining an order, and elements are based on the priority, with higher priority elements appearing closer to the front to the queue. Here, if Q arrow front equal to null or priority is less than user, pointer to Q arrow front arrow data is point to priority. Means this part of code will explain that if the first node of the queue will be empty, then it will return the new node. Else, if the queue in this part where and there is no, and this in this condition we can then we can't implement or we can add any new node to the user, because the already the whole queue is empty, so we cannot add the new user to the exist this already existing node. So this condition this if statement explain about this thing. And now coming to the else statement, here we can add the new user when it is the first node is not null and priority is greater than, and the node can be also add when the priority of the coming node or the new node will have to be greater than the priority of the um, first node of the linked list. Now coming to this part of code, void print queue, and it differentiates between user and driver queues based on the type argument. The print queue function will display the queue, and here the dq function removes and returns the element with the highest priority from the queue. The highest priority queue element will be the near to the front. And the main function will utilizes for the both the drivers and the users. And this is the code for enqueuing or and displaying the priority values of the drivers and both the users. I will run and show it to you. So here we can see the final output of the code. Here I given a user and his ID is 101 and his priority is 3. And second user, his priority is 5 and the priority and the ID is 1 or 2, as same for drivers. And the final user queue, it will the ID, it display the ID and ID of the users, one ID of the user 1 and ID of the user 2. 1 or 2 are the ID of the users and both, and these are the priorities. So now what the priority queue will be function on the person who have highest priority will be allocated the first. Here that happens. See the final output. Here allocated user ID is 1 or 2. Coming to a user, his priority is 5, so he has the highest priority, so he'll get the first chance to get the ride. Same for the driver, the driver with highest priority will be allocated first to the user with highest priority. And this is the part of the priority queue implementation in the project. Now I will explain about the graph, which graph the algorithm we have used to implemented in this project. The graphs are data structures used to find the distances between the points in maps. Now, in our project, we use Dijkstra algorithm for finding the minimum distance between the points. Are the minimum distance between the vertices are the minimum distance between the so from the point of the source to the destination. I will explain how the Dijkstra algorithm will work and its functionalities. Basically, Dijkstra algorithm is a greedy algorithm used to find the minimum distance between the points. Here we are drawing a graph. These are the vertices. Let's name this point as A, B, C, D, E. I'm giving the distance between the A to B as 3, 1, A to C, 1, 7, 1, 5, 7, 2, 7, 2. Now I will explain how we should find the minimum distance between the points. For I'm starting with the point 0. The point where I'm starting, I will take it as a 0, and this is also called a point U. And I want to find the distance between the C to A. V A. I'll take the destination path as V, and I don't know the distance at the point. It will make a infinite. So we have a formula that d of V equals to d of u comma v, d of u plus, to find the distance at the point of v, we have to add the distance of u comma weight of c of the edge come between the u to v. So also, whenever see here, we want to find the point at the d of v. So d of u we consider 0 plus, what is the cost, means the weight between the c to a is 1. 0 plus 1 is 1. Here we'll take the distance of v, we don't know, so we kept as infinite. So 1 is less than the infinite, so we'll cross here infinite and we'll place 1. The distance at the point a is 1. Again, from now I want to find between the distance of from a to b, distance of distance at the point b. Now I'll take this as u and this as v. Again same, 1 plus 3, I'll take this as infinite. 1 plus 3 is less than infinite, 4 is less than infinite, so I'll cut here 4 infinite, I'll place 4. Again, see here, I can also take from distance from C to B. This is 0 plus 7 is less than infinite. I'll take the infinite 7. Now, the distance from C to B is 7. The distance from A to B is at the point at B is 4. Now, we also, before only I told that in this algorithm, we will consider the minimum distance point. So, comparing to 4 and 7, 4 is less than 7. So, we'll take 4. The distance at the point B is 4. Now, from B to E, infinite 4, 1, 5. From C to D, infinite 0 to 0 plus 2, 2, 2 is less than infinite, so we'll keep as 2. Again d to e, 2 here will take as v means infinite will be crossover. 7 plus 2, 2 plus 7, 9. 9 is less than infinite, so we'll take 9 here. Again we come, again see here, we can compare the 9 and 5. If we compare the 9 and 5, 5 is the smaller, so we'll keep the point the distance at the point is 5, and this is the final distance point. Now we can easily take, now here we can easily find the distance between the points. Now if you want the distance from A to B, we can say the distance from A to B is 4, and again the distance from C B to C, the distance from B to C is 5. Like the same algorithm have implemented in our project to find the minimum distance between the points. Now I will explain the code part of the Dijkstra algorithm. This is the code part of the Dijkstra algorithm. అరే 6 నిమిషాలు ఉందిరా, 24 నిమిషాలు అయిపోయింది. Hmm? Here I am the library. Here's the, include std.dao.h, stdlib.h, stdbool.h, and limits.h. These are the C libraries included in the program. And coming to the first point, and here we created a node. This struct node distance, and here for this character we are assigning a value of 50 for the location name, and this is for the inter distance. This is the distance between the locations. In the first part of code structure node, here we are defining, this defines a structure node to represent a node in the graph, and it contains the name of the destination, location, and the distance between the locations, and a pointer to the next node to the adjacency list. యశ్వంత్, నువ్వు వచ్చి నువ్వు చేస్తూ ఉండాలి, తప్పదు, మరి నేను చెప్పడానికి అవ్వట్లేదు. And this structure of adjacent list, this defines a adjacent list structure to represent the adjacency list for a location, and it contains a pointer head node in the list. Next, this is a structure graph. This defines a structure graph to represent the entire graph. It contains the number of vertices, locations, and that represented with V, and an array of adjacency list array. And the next part of the code, struct node pointer create node, and in bracket character, and this is pointed to the destination and the distance between the points. And this part of the code, this function creates a new node for the graph, and it allocates a memory, and it allocates a memory for a node, and set the destination name and distance, and it initializes to the next pointer. Ashwin. And the next part of the code, in get location index, bracket character pointed to the location, and character pointed to the multiple locations, and in number of locations. And this part of code will explain, this function takes a location name and an array of location names, and it returns the index. See, locations of I is equal to 0, and it returns the index of the location in the array, and it's used to find the index of a location in the graph. If you not found the location in the graph, then it will returns as the location not found. Then it will return, and this part return -1 will indicate that location not found. And coming to the next part, and this structure of graph will create a graph, and with a v vertices, and it allocates a memory for the graph, and it initializes a adjacency list, and for each location to null. Void add edge, and this part of code will explain void add edge, struct graph pointed to the graph, and and into so to the source points and destination points. And this whole part of code will explain about, and this function add an edge connection between the two locations, means from the source location to the destination locations, and it creates the nodes with the distance and destination names, and adds them to the adjacency list of both the source and destination locations. And the next void point graph, this point graph function will prints the graph's adjacency list, and it iterates through the locations and the adjacent locations, and printing the names and the locations and the distances. And this part of code is for the Dijkstra's algorithm structure, and this function calculate the shortest path between the locations and given from the given source location to the all other locations in the graph, and it initializes an arrays and set to keep track of the visited locations. And the main function initializes an array of location names and creates a graph and add edges and between the locations and add new places to the graphs. And this is the whole part of the code. Now I will run the code and I will explain output of the code. And this part of code adjacency list of locations. Here we given the locations of Mumbai, Pune, Nasik, Goa, Delhi for the graph. And it will create, and the Dijkstra algorithm will create the adjacency list for every location from Mumbai, Pune, Nasik, Goa. See here, this part of code, this essential list of the specific locations will explain the adjacency list for each location in the graph. For example, the first section of the adjacency list for the Mumbai, it indicates there are roads from Mumbai to Pune and Mumbai to Nasik. From Mumbai to Pune is from 150 kilometers, and for the Mumbai to Nasik 180 kilometers. And the second section is for Pune, and the second section is for Pune, which has roads to Mumbai, Nasik, and Goa, each with their respective distances. And here we entered a location from Mumbai to the destination Goa, and it will displace the distance from the source. From Pune, it is from 150 kilometers, like that. The specific program prompts the user to enter the source and destination. In this case, user specific the Mumbai as the source. Very important. Cut చేయాలి. Coming to the next part, here we enter the proper write details. See this part of the code. This is the output for this part of the code. Here we entered a location source Mumbai and the to destination Goa, and the program prompts the user enter the source from source and destination cities. And in this case, the user specifies Mumbai as the source location and Goa as his destination location. And here it will calculate the shortest path between the distances. It will displace this program uses Dijkstra's algorithm to find the shortest distance from the sources. See from here, the distance from Mumbai is 0 kilometers from the source itself. So from Pune and Nasik are at a distance of 150 kilometers from Mumbai, as they share the same shortest path. And the Goa has the 450 kilometers. Which this is the shortest path to the Goa from all the cities. And this is the whole part of the code for the finding the minimum distance using the Dijkstra's algorithm, which we implemented in. And this is the code for cost calculation. Here we are defining a 10 kilometer for 10 rupees for every kilometer, and this is the whole code. And we are calculating the cost by cost equal calculate cost into distance, means how much distance we travel, and we assign a cost calculation at 10 rupees per kilometer, and the distance is also has been taken in kilometers. We are giving it into float to the both distance and cost, because we can have decimal values of kilometers and cost. So we are given float here. And and we are calculating the cost. And so actually I have to run here, but due to the network issue, I can't. It is reloading like that continuously. And this is the whole code for the cost calculation and algorithms. And this is the code part for the whole project. Now I want to conclude this project. And this is the part of code and this is the part of code and the all we have used it for the creation of this project, and we have worked on, and this is the and these are the algorithms we have worked for this project. And finally I want to conclude this project, and the final conclusion I want to share with you is, and ride sharing is here to transform your transportation and experience. It focuses on quickly connecting passengers, and it give a good explore between the both the customers and both the users and the drivers. And this project mission is to create a seamless and cost effective ride and sharing solutions that benefit both the passengers and the drivers, and with the smart technology and commitment to efficiency. And ride is all about to providing you with an exceptional driving travel experience. Thank you.